You ever, like, when you're trying to get someone to picture something, like a shape,
Uh-huh.
and you just, like, find yourself giving them way more detail than you need to?
Yeah.
Like, I don't know, it's like we equate more details with being more precise or something.
It's interesting, right? Because like in geometry, it's really about finding that like a minimal set of constraints,
Right,
Like,
exactly.
too few, and you've got like an infinite number of shapes it could be.
Right. This is
Because then too many, and they might not even make sense together. You
yeah,
know?
totally. And that's kind of what, like, this whole deep dive with this practical geometry book is about.
Yeah.
Figuring out what actually, like, what really determines a specific quadrilateral.
Yeah. Yeah.
Because they're not always obvious, right?
No, and what's cool is they start off with this example. It's like, imagine you're building a rectangle
Okay. Yeah.
out of sticks, like a craft project,
Oh, yeah.
2 sticks for one side, 2 for the other.
You think you've got it, but it's all,
Wobbly.
yes, floppy rectangle.
Exactly. And then they're like, okay, add a diagonal stick. And boom, suddenly.
Rigid.
It's amazing how much that one.
It's counterintuitive, right?
Totally. It's not just adding length, it's adding a relationship.
Yeah, it's defining.
Constraint between those parts.
That example just blew my mind when I read it.
It's such a good visualization,
It is, but then it gets even, like, more in-depth.
Mm-hmm.
Because they get into all these different combinations of measurements
Right.
that can be used to, like, fully nail down a quadrilateral.
It's not just any sides and any angles. It's very particular.
So there's, like, a method to the madness.
Absolutely. Yeah. Like,
Yeah.
you might think, okay, 4 sides and a diagonal, that's got to be it, right?
Right. Seems logical.
And that works. But then they're like, hold on, 2 diagonals and 3 sides, that also works.
What?
Or even 2 sides and 3 angles.
So you can define the same, like, end result shape
Yeah.
using different starting information.
Exactly. It's like your destination is the shape. But there are multiple routes to get there.
Okay, but there's got to be some rules, right?
Yeah.
Like, it can't just be A-N-Y.
Oh, absolutely. There are definitely rules.
Because, like, I'm picturing if you just had 2 sides and then a random angle somewhere,
Right. It's not just the number, it's the relationship.
it could still be all wonky.
Exactly. That's
Yeah.
where this idea of like included angles comes in.
Oh, yeah, the book had a whole section on that, right?
They give this great example. Let's say you've got, 2 sides of your quadrilateral measured out.
Okay.
The angle you measure can't just be A and Y angle. It has to be the one specifically where those 2 sides meet.
So it's like that angle locks those 2 sides into place in a specific way.
Exactly. It's
Yeah.
like that angle is defining their relationship.
Okay, now it's making sense.
And the textbook does a really good job with like diagrams and stuff. Because sometimes you just have to see it to get why it matters.
Totally. So we're not just randomly measuring, we're figuring out the specific combinations that, like, force a quadrilateral to take a certain shape.
It's like puzzle pieces almost,
It gets like those geometry puzzles.
Hmm.
But now we get to understand the WHY behind them. And this is where it got, I don't know, extra interesting for me. Because they start talking about, like, squares and rhombuses,
Right.
which you'd think, oh, those are simple.
Yeah, they seem straightforward.
All sides equal, done.
But there's more to it than meets the eye, right?
The book was pointing out all these, like, hidden depths.
It's a good example of how, in geometry, what's implied matters just as much as what's stated outright.
Okay, so, like, with a square, we all know it's got 4 right angles.
Right.
But you don't usually see that written down in the definition, do you?
Exactly, because it's already baked in.
It's like, we don't need it spelled out.
Those right angles are an inherent property of having all sides equal.
So it's like that diagonal stick in the rectangle example. We didn't need to be told it was making right angles.
Right. It just
It's like a consequence of the whole structure.
Exactly. Sometimes that like hidden information is what truly locks the shape in.
Whoa. Okay, this is getting kind of deep.
It's like there's this whole deeper level of understanding.
Yeah, it's not just about the numbers themselves. It's like, it's about the logic behind them.
That's what makes geometry so elegant, It's all connected.
Okay, so we've gone from building shapes with sticks to, like, uncovering these hidden properties of squares. Where do we go from here? What else is in this book?
Well, they leave us with a challenge, actually.
Ooh, I like a good challenge.
They want us to try and come up with our own WN set of 5 measurements
Okay, so, like, just pick any 5 lengths or angles.
and see if you can make a quadrilateral out of them.
Sounds fun. Is that all?
Well, there's a catch.
There's always a catch.
It's one thing to draw a shape that, like, looks plausible,
Right.
But can you prove that those 5 measurements will always create a valid quadrilateral?
Wait, hold on, back up. You're saying there are combinations out there that might look like they'd work, but actually, like, break the rules of geometry somehow.
It's entirely possible, and that's the real challenge.
So are we saying that, like, there's a difference between, like, drawing a shape that looks right
Yeah.
and actually, like, knowing for sure that it's legit?
That's exactly it. It's like moving beyond just like doodling around and getting into the real nitty-gritty of like geometric proofs.
Oh, yeah, proofs. I remember those.
Can you actually demonstrate, like without a shadow of a doubt, that those 5 measurements, no matter what, will always give you a quadrilateral?
Okay, so it's like not just drawing it and being like, well, it looks like a duck, so
Yeah.
it's got to be, like, mathematically sound, ironclad.
Precisely. It's one thing to say, like, oh, I baked a cake, but can you give me the recipe? Can anyone recreate it?
Oh, I like that analogy. So we're not just baking the quadrilateral cake. We're writing down the recipe so anyone can bake the exact same cake.
Exactly. And that's where I think things get really interesting.
Yeah, because now it's like we're not just learning the rules. It's almost like we're trying to break them, or at least see how far we can bend them.
And that's where the real learning happens, right? When
Yeah.
you understand the why behind the what. Like, the book is basically giving us the tools to become, like, mathematical detectives.
Ooh, I like that. Geometric detectives.
Going out there, experimenting with different combinations, seeing if we can, like, stumble upon these hidden impossibilities.
So to recap for our listeners, because this has been quite a journey, we started off talking about, like, describing a rectangle, and now we're basically on the verge of, like, writing our own geometry textbooks.
And the crazy thing is, we've only scratched the surface. There's so much more to explore.
So much more to figure out. So, listener, here's our challenge to you. Go out there and don't underestimate the power of constraints.
Ooh, good one.
Whether you're building something, making a decision, even just thinking about a square, it's all about those relationships, those hidden connections.
And hey, maybe you'll be the one to discover that new set of measurements, the one that seems possible but actually turns the whole quadrilateral world upside down.
That would be amazing. All right, until next time, keep those brains buzzing,